Okay. Hi students. Okay. In this video, we are going to discuss about modern physics. So it is related to the study about both atomic structure and nucleus. So atomic physics and nuclear physics combiningly we can call it as a modern physics. And in this modern physics, we have a number of discoveries given by different scientists and their inventions, and these inventions and discoveries we are going to apply for our different newly invented instruments or improvement in the science field, science and technology. All these, the basic requirement for all these improvements or increment in the science and technology are the modern physics. So modern physics is very essential for increment or improvement or in the progress of science and technology. So now we are going to discuss the topic of this modern physics. In this, mainly we can be concentrate about the discoveries given by the different scientists. So the modern physics is the study about atom as well as the nucleus is called as a modern physics, or it is a combination of both atomic physics and nuclear physics is called as a modern physics. In this, we are going to discuss the discoveries given by different scientists. All these discoveries or inventions you might be observed or learned in your 11th PUC of chemistry part. So maybe first 2-3 videos you feel it is somewhat theoretical, but it is very interesting provided if you are listened or seen concentrating. Okay, now we have here discoveries given by different scientists and they got Nobel prizes. Here regarding structure of atom, the Dalton is a scientist who studied the modern atomic theory in the year of 1803, and after that there are different scientists like Thomson, Rutherford, Niels Bohr, Compton, Einstein, de Broglie, Heisenberg. So number of scientists who contributed towards the revolutionary evolution of the structure of atom, and all these information provided by different scientists. So now I can give the list of scientists who contributed their information to the society regarding the inventions. They are, we have the first person, his name is you can be observed Röntgen, who got a Nobel Prize in the year of 1901 for the contribution of X-rays. For the contribution for the invention of X-rays, he got a Nobel Prize in the year of 1901. And second one, J.J. Thomson, in the year of 1906, he got a Nobel Prize for the study and determination of E by M of electron. To determining the value of E by M, that is specific charge of electron, for that the Thomson got a Nobel Prize in the year of 1906. And next one, you can be observed Einstein. So he got a Nobel Prize in the year of 1921 for explaining photoelectric effect and Niels Bohr also got a Nobel Prize in the year of 1922 for structure of atom. Successively explained about the atomic structure, for that he got Nobel Prize. And next one, you can be observed the other, that is a Millikan, also got a Nobel Prize in 1923 for elementary charge of electron, for determining elementary charge of electron. He got a Nobel Prize in 1923. And similarly, the other person, like you can have A.H. Compton, got Nobel Prize 1927 for his Compton effect, where we can be get all these information we can be discuss once we are moving forward, but just that inventions I am giving, and for that inventions they got Nobel Prizes in the respective different years. Now in this chapter, first we can be discuss related to discovery of electron, specific charge of electron, elementary charge determined by the Millikan, and all these information once we completed, then we are getting into the effect of charge these electrons when they are striking on any surfaces, especially from metal surface. How we can be get that ejection of electrons, that is a photoelectric effect given by Einstein. All these experimentally we can be determined, but as of now we just start the discovery of electron by the discharge tube phenomenon. By using discharge tube phenomenon, we can discuss the discovery of electron. So in this, discovery of electron by discharge tube method or phenomenon. So in this, what is a discharge tube? So here discharge tube is discharge tube. So what is a discharge tube? It is a long cylindrical glass tube having length about half meter and diameter 4 centimeter, that is used and applicable for discharging of gases in it. Then that cylindrical glass tube is called discharge tube. So here discharge tube is a cylindrical glass tube which is having length about half meter, diameter is 4 centimeter, and which is applicable and used for discharging gases in it. Then we can call that glass tube is called as a discharge tube. Correct? And in this gases, so as we know very well about the gases, that is every gas is generally, it can be having the property of insulation at normal temperature and pressure. At normal temperature and pressure, the gases are very good insulators. They does not allow the flow of charge, that is does not conduct. They are insulators. But the gases can also has the property of conduction when varying the conditions, like varying the temperature and pressure, or the gas is maintained at very high potentials. when you are applying the very high potentials to the gas and varying the pressure at very very low pressures, the same gas can has the property of conduction. So applying that condition and studies the gases behavior in the discharge tube, and accordingly we can be observe the different information at different pressure variations, and at the end of this one, at a particular pressure, at a particular potential applied in the discharge tube for a given gas, we can have the information for getting the discovery of electron. So now we can be get that by explaining at different pressures for a gas in a discharge tube. Okay. Now you can be consider here first condition I am taking here. It is at pressure of 10 mm of Hg and potential or voltage is equal to very high voltage. It is about 15,000 volts to 20,000 volts potential we have to apply. And in these conditions, how that gas behaves in the discharge tube. Okay, this is a cylindrical glass tube and we can call it as a discharge tube, and in this we can be arranged. There are two electrodes. They are maintained. One is connected to low potential, that is called cathode, and one is given to the positive terminal, that is known as anode. And there is a side opening is there which is used to maintain the pressure of the gas, that is the pumping of the gas outside or inside. Accordingly we require the pressure is maintained in the gas, in the discharge tube for that gas. So these are given to the connections to, this is for negative and this is for positive. Here we can be applied the high potential, high voltages. That high voltages is about 15,000 volts to 20,000 volts of potential we have to apply for this gas. So now the pressure is maintaining 10 mm of Hg and the potential is applying 15,000 to 20,000 volts for this gas. Now this gas having the property of conduction, that means at this potential, at this pressure, we are observed that this gas is getting discharged. There we can be observed in the discharge tube is, it will be a sparking. The sparking of the gas particles can be observed and which can be make some sound, that is crackling sound we can be hear. So at this pressure with this voltage we are observed in this discharge tube is there is a spark you can be observed for the gas particles, and also which makes some sound, that is we can call as a sparking sound. So that is we can be see at this condition as here sparks you can be observed and which makes a crackling sound. Sparks and crackling sound we can be observed at this pressure with these potentials, that is 15,000 volts to 20,000 volts when we applied. And if we varies the pressure by maintaining the potential is same, there we can be observed how the gases behaves in the discharge tube. That is we are decreasing the, lowering the, reducing the pressure of the gas and maintaining the potential is same, how that gases behaves in the discharge tube. Okay, that we can be see number of cases. So now getting into the second, that is here when the pressure is reduced to 5 mm of Hg and the potential applied for the gas is remains constant. We are maintaining same. That is here if it is second case, if you observed at a pressure of it is 5 mm of Hg and potential is same, V is equal to it is 15 kilovolts to 20 kilovolts, it is maintaining C. But what we are doing, decreasing the or lowering the pressure applied for the gas. How we can be decrease the pressure? From this pump we can leak out some of the gas so that the pressure of the gas can be decreases. So if you are maintaining the pressure of 5 mm of Hg at a potential of 15 kilovolts to 20 kilovolts, then what are the observations we can be seen in the discharge tube? At this pressure with this potential, okay, now at this pressure of 5 mm of Hg and the potential of 15 kilovolts to 20 kilovolts, how the gas behaves in the discharge tube. So at this pressure and potential, you can be observed here it is at cathode and at anode, and here the pressure you can be varied. Now the gas in the discharge tube is, the gas is converted into a streaks like formation. Some of the gas is moves into towards anode. The gas particles which are making into or which is pushed towards the anode, and there is a dark space is forms between these gas particles, and there is this one, that is a cathode. So here this one is what it is called as it is positive column, and the dark space between the cathode and the positive column is called as Faraday dark space. So at this pressure with this potential, you can be observed the gas is, some of the particles, the gases are moved pushed towards the anode, and we can call these particles called as a positive column, and there is a space, a dark space is formed between these gas particles to the cathode. The dark space is named as a Faraday dark space. This is observed when we have here it is at a pressure of 5 mm of Hg, and you can be observed here at a potential is maintained same. Now here this positive column is observed in the discharge tube with different colors based on the gases we are used here. That is, for different gases when you are using, so we can be get different colors observed in the discharge tube. That is, if it is air, if you are using in the discharge tube, then you can be get here it is a purple red color you can be observed. The discharge tube will become totally, you can be observed, this positive column will become purple red color when you are used the gas as a air. If you go for hydrogen, then you can be observed in this positive column color will be changes, that color is blue color you can be observed, and if it is a nitrogen gas it is red color. If it is observed to be having chlorine gas, it is green color, and if it is a neon gas, then you can be observed here bright red color you can be get. So this colored, fluorescence colored formed in this discharge tube is based on the gas we are taking in the discharge tube. So according to the gas, the color of the discharge tube be modified at a pressure of 5 mm of Hg and applied potential of 15 kilovolts to 20 kilovolts of potential. So under these conditions, you can be observed the discharge tube will be formed or observed to be having the different colors with respect to different gases. That is, for air purple red color, for hydrogen you can be observed blue color, for nitrogen it is red color, for chlorine it is green, for neon gas you can be observed it is bright red color. If you go for next, if the pressure of the gas is further lowered, further reduced, let it be this pressure will become 5 mm to, let it be this 2 mm of Hg. Under that pressure, what you can be observed in the discharge tube, how it can be formed. So now you can be go for the other case, that is at a pressure of 2 mm of Hg. Under this pressure, you can be observed in the discharge tube. The gas behaves and it will be forms as, here you have the cathode, it is a anode, and here the pressure pumping, the pressure can be varied, and in this the positive column will made further, it is shrinking, it is further pushed towards the anode, and there is a near to this cathode you can be observed, there is a glow nature you can be seen, that is called as you can be observed negative glow. So negative glow will be moves away from the cathode, and negative glow moves away from the cathode, and positive column shifted further, shrink towards the anode, positive column, and here there is a dark space between these negative glow and positive column. This dark space is Faraday dark space, and there is also form one more dark space between cathode and negative glow. This dark space is named as Crookes dark space. Crookes dark space you can be observed at a pressure of 2 mm of Hg, where you can be seen there is a dark space between the cathode and negative glow is known as Crookes dark space, and the dark space formed between the negative glow and positive column, that is called as a Faraday dark space. Okay, these are the changes observed in the discharge tube when you reduce that pressure from 5 mm of Hg to 2 mm of Hg. Now further decrease in the pressure of gas in the discharge tube, let it be, it is 1 mm of Hg, and in this case you can be observed the gas can be modified, and the discharge tube can be observed as at the pressure of 1 mm of Hg with potentially same, that is 15 kilovolts to 20 kilovolts. So under these conditions you can be seen the discharge tube as you can have here anode, and here you have the cathode, and at this pressure all this positive column is dividing into number of layers. All these positive column is converted and form as a layers which are known as striations. We can be having here all these positive columns are made converted into or formed into a layers. This layer is named as striations. So at this pressure there is a change observed here, it is the positive column in the discharge tube is converted into or formed into number of layers, dividing into number of layers, and these layers are called as striations. And at this case you can be observed these dark space will be all are moves towards the positive column, and only you can be observed the remaining part is Faraday dark space is formed here, and here to here you can be observed this is a negative glow, and here this is a Faraday dark space, this is negative glow, and here this one is Crookes dark space. And nearby the cathode it will be looks like a dark itself. So these are the observations you can be see at a pressure of 1 mm of Hg with the potential of 15 kilovolts to 20 kilovolts. So here we required or we made further reduce in the pressure. It is 1 mm. If it is less than 1 mm, that is 0.01 mm if you taken, then what are the changes observed in the discharge tube? How that gas is behaves? If the pressure is becomes 0.01 mm of Hg, under this pressure you can be observed that in the discharge tube totally it will be observed like a dark one. There is nothing can be observed, there is no light or no positive column, everything will become dark. So that is here from total this discharge tube is completely dark, that is formed as a Crookes dark space only. The total discharge tube observed as a dark and which is named as a Crookes dark space, except one region where behind the anode you can be see there is a fluorescence. There is a fluorescence behind the anode. So at this pressure, with that high potentials, the gases are made to be produce some invisible rays. That invisible rays are passing from cathode to anode. Because of that invisible rays, once they made collide with that glass tube, there is a fluorescence produced behind the anode. So because of this fluorescence, we can be say that some rays are passing from cathode to anode. That rays are invisible. We cannot be see those. And these invisible rays are nothing but we can call them as cathode rays. Because of there is rays are passing from where to where? Cathode to anode. But we are not seeing. How we can be decide it is passing from cathode to anode? Because behind the anode we are observed to be get a fluorescence because of some rays are coming from cathode to anode. So because that rays are known as cathode rays. Because of that rays only made interaction with the glass tube, we are getting that fluorescence and which is forms behind the anode. Right. So these invisible radiations or invisible rays at a pressure of 0.01 mm of Hg with high potential of 15 kilovolts to 20 kilovolts. There you can be observed cathode rays are produced. That is here at pressure is 0.01 mm of Hg and the applied potential voltage is 15 kilovolts to 20 kilovolts. There you can get cathode rays. Okay, these cathode rays are having the different properties and studies about these cathode rays, and after making the different experimental studies about the cathode rays, they are named as electrons. Okay, what are the properties and what are the studies about these cathode rays? Okay, that is we can have these cathode rays named as electrons by studying the properties of these cathode rays. And this name is given by a person, his name is John Stoney. The name of the person who given the electrons for cathode rays, the name is John Stoney. He given this electrons name for the cathode rays after studies made for cathode rays, how they behaves, what are the properties for these cathode rays. So that is after the studying those, he given the name of these cathode rays are nothing but electrons. So like this, these invisible radiations, when you are maintaining the pressure of very low pressure 0.01 mm of Hg and maintaining the high potentials, then the gases can has the property and they can be produced or they can be get some invisible radiations from cathode to anode. They will be flow or they will be travel. These invisible radiations are nothing but electrons. Because of the two electrons only, when they are moving with high speed and colliding the glass tube, there the fluorescence can be produced behind the anode. So because of that, we can be say the electrons are the negative charges only flowing from cathode to anode. Because of them only we are getting the fluorescence behind the anode. Correct. Now we can be see the properties of cathode rays. So what are the properties of cathode rays? That is, we can be observed here properties of cathode rays. So properties of cathode rays. So here the first one, these cathode rays are always travel along the straight lines. So here travel along straight line, along straight lines. That is the first one. And these cathode rays can produce fluorescence and they can cast shadows. So here they can cast sharp shadows, produce fluorescence. and they can travel with a velocities about 10 power 7 meter per second. Have the velocities in the order of 10 power 7 meter per second, and they can deflect in both electric and magnetic fields. When these cathode rays are propagated or travel from any field, either it is a magnetic field or electric field, these cathode rays can be gets deflected. So here they deflected by both electric and magnetic fields, and these can be produce X-rays. And also when these cathode rays are propagated or travel from the gas, that gas can be become ionization. That means these cathode rays has the property of ionize the gases through which they pass. So here they ionize gases. So these are the properties of cathode rays. So right, with this video concluded. Signing off. ఎంత టైం అయింది?